Okay, so first question says the point P where 6 and minus 4 are the coordinates, y on the curve y is f of x. Find the point to which the coordinates P are mapped onto the curve with these transformations here, right? So if we look at part A, we have a transformation where we're adding 2 inside the bracket. If we go to our key, we see that adding something inside the bracket is going to shift it to the left and minus it from the x coordinate. So for part A, pretty simple. It's going to be minusing 2 from the x coordinate, so it's 4 and minus 4. Now part B says y is the inverse of f of x, right? So this is essentially a reflection in the x-axis, which means that any x-coordinate becomes a y-coordinate, and any y-coordinate becomes an x-coordinate. So all that's going to happen here is minus 4 and 6. This applies to all cases. If it was 6 minus 5, it would just be minus 5, 6, right? Then part C says y is 2 lots of the modulus of f of x minus 3. Well, just remember that y is f of x, right? So we can go ahead and say that 2 lots of the mod of the y coordinate minus 3 is the transformation, right? So if we mod y, then we're going to get 4. 2 times 4 is 8, then minus 3 equals 5, right? Which means the coordinate for y is just going to be 5, right? Because y equals this. So we can just say that the coordinates are 6 and 5. Okay, so question 2 says the circle C has this equation here. State the coordinates by the radius and determine if the origin lies inside the circle C. So let's just consider part A for now, right? The general equation of a circle is just going to be x minus a squared and y minus b squared equals r squared, right? Where x is like a variable coordinate and a and b are the centers, right? So we see here that a is one of the centers, so we're going to set centers minus a minus b, right? And then if we consider this equation up here, we see that in this case a is 3 and in this case b is minus 4. So minus a is going to be minus 3 and minus 4 is going to be 4. But I find the radius, right, in your equation is simplified third. Well, if we see that r squared is the radius here is 24, so that means r squared is going to equal 24, which just means that r is going to be the square root of this, which I believe is 2 root 6. We'll check on calculator. Yes, 2 root 6. Okay, now part B says determine, given a reason, whether or not the origin lies in the side of the circle C. So what we can do here is we can find the distance between the center of the circle, which is this, and the origin, right? So if I illustrate this, let's say we have this circle here, or should we use the correct coordinates? Minus 3 and 4, right? So we have a circle with a center here, and the radius is 24. If the distance between the origin and the radius, the origin and the center, sorry, is greater than the distance between the radius, or greater than the radius, should I say, then that means it will not lie in the origin. But if the distance from the center of the circle to the origin is less than the radius, then it will. We can see that here, if I go back, so let's say that minus 3, 4 is actually something like this, and the center is about here. The radius is all the way over here, but the distance to the origin is just here, right? So we can just say that distance to origin less than radius, and it will lie in the circle, lie in the origin, sorry. So how are we going to do that? Well, we're going to use the distance formula, right, which is just the square root of x2 minus x1, so minus 3 minus 0 squared, and y2 minus y1, which is just 4 minus 0 squared. And then you put that in your calculator. And you get that your distance is going to be 5. Now, 2 root 6 is equivalent, or the radius is equivalent to about 4.8991. So we can see here that the radius, 4.899, is less than the distance to the origin. And when we said on that circle, if the radius is less, then the center will not lie. The origin will not lie inside the circle, right? Because the distance to the origin is longer than the radius, and the radius is the furthest point the circle will go. So we will just say that 5 is greater than 4.899. Therefore, let me just see what the question wants. Origin doesn't lie inside the circle. We got 5 marks. Okay, so question 3 says the first 3 terms of an arithmetic sequence are 6k, 10, and 2k. K is a constant, find the value of k. And then also find the value of the sum of the first 50 terms, right? So let's just tackle part A first, right? What do we know about this arithmetic sequence here? We know that there's going to be a common difference each time, which we're adding on, and that will repeat forever. Let's say the next one was 1000k or 100k. Whatever that added d was would have to make it to the next value, right? Then what we can say is if we do 10 minus 6k, that will give you the value of d, right? Because we're doing 6k add d equals 10, every illustration here. 6k add d equals 10, so d is equal to 10 minus 6k, right? Then we do the same here. Well, we know that the common difference has to be the same each time, so we can just find another equation for this, right? So 10 add d is going to equal 2k, which then means d equals 2k minus 10. And if we have 2 equations of d, we can just make them equal to each other, right? Because d is going to be the same both times. So then just solving here, we add 6k to both sides. Add 10 to both sides as well. And we get 20 equals 8k. And then obviously just dividing by 8 now, we're going to get that k is equal to 5 over 2. So correct. Part B says, hence find the value of the sum of the first 50 terms. Okay, now part B says, hence find the value of the sum of the first 50 terms. Well, we know the sum for this, but we don't know the first and last terms. We could figure them out. It would take too much time. I wouldn't recommend doing that. We're just going to use this formula, n over 2, brackets 2a, add n minus 1 of d times d, sorry. So then we need to find n, which is our number of terms. A, which is our first term. And then d, which is our common difference. Well, we already found k in the first part, right, which is 5 over 2. So that means we can find the first term, which is 6 times 5 over 2, right? Which is just going to be 15. Which then means if we look at our sequence, we say that it's now 15 and 10. Well, what's happened here? We've minus 5, right? And we can check this by doing 2 times 5 over 2, which is going to give us 5, which again, we've minus 5, right? So that means our common difference is going to be minus 5. And we've already shown that our first term is 15. So we can say n is the number of terms, which is 50, divided by 2. And then 2 lots of the first term, which is 15. Add n minus 1, which is the number of terms, minus 1, so 49, times by the common difference, which is minus 5. Remember to put minus because we are taking away 5 each time. So 49 times minus 5, add 30, times 50 over 2 is going to be minus 5375. And don't be concerned that the sum is negative, because we're taking away each time. We can see it's eventually going to be 0, then minus 5, then minus 10, so we're adding a lot of negative numbers together, right? So that's another nice 5 marks. Okay, so the next question gives us a cubic of f of x, and it tells us when we input minus 4 as x equals 0, and then it wants us to write f of x in the form. of this. And then we have to prove there's no root. Okay, so every time you see a question where an input of x leads to 0, you know it's factor theorem, right? So we're saying if x equals 4 or minus 4 in this equation, there is no output, right? So that means that a factor would be x at 4, right? So then we can see here x at 8, that's going to be our factor, right? So then now all we have to do is do some polynomial division. So we draw our little bus stop, and we put our cubic in here, where this 3x squared minus 16x and 16, and then we just do some simple polynomial division, right? So what do we times x by to get 2x cubed? Well, that is going to be 2x squared, right? So then we're just going to put this here. And then what do we, so if we times this by 2x squared, we have to times 4 by 2x squared as well. So it's going to be 8x squared, right? And then we take them away, so 2 minus 2 is 0, 3 minus 3 is minus 5x squared. Bring this one down, so it's minus 16x. So what do we times x by to get minus 5x? Well, that's going to be minus 5, right? Minus 5x. So we do the same thing, times these together, we get minus 5x squared. Times this together, we get minus 20x. Now, be careful with your sign, say, just put it in the calculator. Minus 16 and minus 20. That's going to be 4x. Add 16. And then we just finish it off, right? Plus 4, because we times x by 4 to get 4x. We don't really have to worry about the 16 because we can already see we've got the quadratic that we needed. And if you went to completion, which I'm just doing now, we'll see the equation just ends, right? Because 4 times x gives us 4x, so then 4 times 4 is 16, we take them away, we get 0, right? So that means that our final form is just this x and 4, bracket 2x squared minus 5x and 4. Now, part B asks us to prove that there's only one real solution and it's minus 4. So we're just going to ignore this minus 4 here for now. I'm going to look here at our quadratic. So there's many ways we could look at this, right? We could complete the square, we could do quadratic formula, but a simple way to do this is just use the discriminant, right? Now the rule is, if the discriminant is less than 0, there's no solutions for this quadratic. So we just put A, B, C. So b squared, so minus 5 squared minus 4 times a, which is 2, times c, which is 4. Now we put this in our calculator, we can already see it's going to be negative, right? 25 minus 4 times 2 times 4 is going to be minus 32, right? Which is going to equal minus 7, which is less than 0, which then means that there are no resolutions. So that means our only other factor or bracket was x at 4, which means x at 4 is only factor with a solution. Simple. Okay, a nice little 3 marker here where we're going to express a limit to the integral and then show that a equals k, right? So when we look at this limit, it can look very intimidating, right? But we're basically just saying the summation of all the inputs between x is 1.44 and 2.89 for this function here will give us the area under the curve, essentially, right? So how else do we know that? Well, we know that by integration, right? This is just a simple definite integral, right? So now all we have to do is we have to take our function, which is going to be this, and our two limits, 1.44 and 2.89. So we can rewrite this as the upper limit, which is 2.89, and the lower limit, which is 1.44, and our function, which is just 2 over root x. And don't forget the dx, right? Now, part B tells us to evaluate this integral and find a value of k. So what we'll do is we'll rewrite this. We'll say 2 over x to the power of a half, which is the same as 2x minus a half, right? So then we just have to integrate 2x minus a half between these two limits, which is like this. So I'm going to add 1 to the power, so add 1 to minus a half is going to be a half, right? And we're going to divide 2 by that, so it's going to be 4x to the power of a half between the two limits of 2.899. 89, sorry, and 1.44. So we just do 4 times 2.89 to the power of a half, and we get 34 over 5. Then we do 4 times 1.44 to the power of a half, and we get 24.5. Then we just take these away. Or 24 over 5, sorry, let me take these away. So it's just going to be 10 now. Oh, sorry, 2 here. 10 over 2. So there's 2, so then k equals 2. Simple. Okay, so question 6. The scientist is monitoring the flight of seabirds. The height above the sea is modeled by this equation here, where t is seconds. Well, that's significant that t is seconds. And a, b, and t are constants. Given that the bird was 17.6 meters above the sea at 4 seconds and 11.9 at 9 seconds, find a complete equation for the model. Well, what I'm thinking of is we can just substitute the values we know into our equation here, which is h equals a minus b t to the power of 1.5. Right? Well, it's a capital B. Doesn't really matter, but for accuracy, right? So the height is 17.6. We don't know a, we don't know b, but we know that t is 4 to the power of 1.5. And then we do the same here. 11.9 equals a minus b times 9 to the power of 1.5. So if we just tidy this, 4 to the power of 1.5 is going to be 8. Let's copy this, bring it down. Nice. So we're saying b times 8, right? So just a and b. And then 9 to the power of 1.5 is 27, so minus 27b. Now, if you have a good calculator, you can just do this simultaneously on your calculator, but we will do it by hand just to show. So we'll just say 11.9 equals 8b. Okay, so we get to this point here, then we're going to take away 17.6 from both sides. It gives us minus 5.7, and then 8 minus 27 is going to be minus 15, right? So minus 19. So minus 5.7 divided by minus 19, we're going to get that b is equal to 0.3. And now we can just go back to this equation of a here. We can say 8 times 0.3 adds 17.6, so a is going to equal 20. So that means we have a full equation where h equals 20 minus 0.3 t to the power of 1.5. Find, according to the model, the height of the bird's nest above the sea, not the nerd, the bird. Alright, so if we think about this, right, the height above the sea is just going to be when the bird hasn't flown anywhere, right, or flew anywhere. Because if we just consider like the bird is at this point here, then it goes all flying around. Obviously, it's a quadratic, right? So it's not going to be exactly that. But the point where the cliff is just when the bird has made no movement. So we can just say that h equals 20 minus 0.3 times 0. Because the time of flight is 0 seconds, right? T seconds after it leaves the nest. Hasn't left the nest, hasn't got any time, so it's 0. So that just means that h is going to be 20. Okay, part C says, find the limitation of the value of t. Well, with this model, right, we never want the height above the sea to be negative. So what we can do is find the value of t which makes h negative. So let's just say that h takes its minimum value of 0. It's going to equal 20. minus 0.3t to the power. I'm going to put it as 3 over 2 just to make it clearer, right? So then we can just rearrange this one. 20 equals 0.3t to the power 3 over 2. And we can just divide both sides by 0.3, so we get 200 over 3 equals t to the power of 3 over 2. And we can just raise both sides to the power of 2 over 3, right? Because 3 over 2 times 2 over 3 is 1. So 200 over 3 to the power of 2 over 3 is going to give us 16.44 equals t. And that is the limit for the value of t. And just to make sure it's clear, t to the power of 3 over 2 to the power of 2 over 3, we times these two together and it equals t, right? Okay, question 7. It was a poorly answered one by a lot of students, but we'll try and work through it. It's a very hard question though. So the figure 1 shows a sketch of a curve with the equation y equals f of x, where f of x is a quartic expression. We're told it has maximum turning points at these points here, and it crosses the y-axis at this point as a minimum turning point here. Find a set of values of x for which the derivative is greater than or equal to 0, writing your answer in set notation. Well, what is the derivative, right? It's the rate of change of the graph. So we're basically saying to find the points or the values of x for which the derivative or the rate of change of this graph is positive. Well, there's 2 points, or there's points I can spot right now, right? Where the graph is becoming more positive, right? It's changing positively. All the values on this side of 1, or minus 1, sorry, and all the values between 2 and 5 is when it's increasing, right? Because you can see it between minus 1 and 2 it's going down, after 5 it's going down, right? So we can say that when x is less than or equal to minus 1, it is increasing, or is greater than 0, right? Greater than or equal to 0. And between 2 and 5 it also is, right? So then, now we just need to write in set notation, right? It can be a little bit tricky, but once you know it, you know it, right? So we have to do these brackets. I'm going to say x, where x is a set of real numbers. X is then going to be less than or equal to minus 1, as we said. Union x. You don't always have to do this set of real numbers thing, but I just like to do it for clarity. Say x is between 2 and 5, right? Because we see this is the point where the graph has a positive rate of change. Okay, now part B says find the equation of C. You may leave your answer in factorized form. We're definitely going to be doing that, right? Because we do not want to be dealing with quartics, right? So, what do we actually know from the information given to us here? We're told that it has maximum turning points at minus 1, 5, and 0, and it crosses the y-axis at this point. Well, what we know about these points, right, is they're repeated roots. But why do we know that? Well, when the graph is increasing, we get a solution at minus 1 here, right? But then also when the instant the graph begins to decrease, it also has a solution at minus 1. And the same thing applies here. The graph is increasing. At this point, there's a solution at 5. It changes just so slightly by a value of like 0.0001 of x, and we get another root at 5, right? So then if we quickly write down just the general equation for repeated roots, right? It would be a, because the graph has been stretched by, because it's not a traditional quartic, right? So it's been stretched by a scale factor. And then we just have a root of b, which has been repeated, and a root of c, which has been repeated. That's why we have squared, right? And you'll notice it makes a quartic if we expanded all this out, right? So then, what is b and c, also known as our solution as well, which is minus 1 and 5, right? So that means we're going to say y equals a bracket x minus 1 squared. Oh, sorry, plus 1 squared, because there's a root. X minus 5 squared then, right? And now we pretty much have the equation, right? We have it in at least the quartic form which we wanted. So we can just substitute values of x is 0 and y is minus 75 to find a, right? So we say a bracket 0 and 1 squared multiplied by 0 and minus 5 squared. And then we can say minus 75 is going to equal a multiplied by 1 multiplied by minus 5 squared, which is 25. So minus 75 equals 25a. So that means a equals minus 3, right? So minus 3 brackets x had 1 squared bracket x minus 5 squared. Now you could consider the roots x had 1 separate without the squared and you'll get the same answer. You could try and use just ax4, like you could try and use this formula, right? ax4 and bx cubed and so on. But it just makes it very confusing and too long. So I'd recommend just before your exam, you make sure that you know quartic, cubic, and quadratic general equations, right? And now, okay, part C is an interesting one, where the curve C1 has equation y is f of x plus k. It intersects x-axis at 4 places. Find the range of values for k. Well, what is plus k? That's just a translation upwards or downwards, depending if k is negative or positive, by a value of k, right? So if we go back to this graph here, let me try and demonstrate this. So if I copy the shape a little bit of this graph, no, let me just do this. Right. If we shift out by k, we go up, 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 up. We're getting 4 points of intersection, right? We see the original graph only has 2 because of the repeated roots. We go up, up, up a tiny bit, and we get 4 solutions, right? If we keep going up, 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 still got 4 solutions, go a little bit more until the minimum point touches. Then we get a repeated root at x is 2, right? Which means we only have 3 solutions. We have 1 at this point, 1 at that point, because 2 twice, and we'll have 1 at this point, right? So we need to find the value of k, which brings 2 to the x-axis, and it's going to be, well, which brings the graph to the x-axis, sorry, which will be the largest value of k it can be. And then k also has to be greater than 0, because if it goes down, we're going to have no solutions. And if k is 0, then nothing changes, right? Look, if we're shifting down, we have no solutions, no solutions, no solutions, right? So that's this, right? So we know that k has to be greater than 0, we established that, because otherwise it's either not going to shift or it's going to go under and have no solutions. So we want to find the value of k here, where this quartic makes 2 at the x-axis. Well, that means that x is going to equal 2, right? Because we're saying that there's a solution, or a repeated root when x is 2. So if we find the output for the solution, then that will be the greatest value of k, right? So y is equal to minus 3 brackets 2 add 1, 3 squared, multiplied by 2 minus 5, which is minus 3 squared, right? So then minus 3 times by 81 is going to be y is minus 243. So that means that, and we can ignore the negative sign here, that means that it's going to be 243 shifts up this whole way by plus 243. And that's when x is 0, when y is 0, when x is 2, right? So that means we want it to be just less than 243, so we'll always have 4 solutions. So the final answer is 0, it's less than k, is less than 243. Okay, question 8. We have a proof question, right? We want to prove that the square of any number can be expressed in the form 5n or 5n plus or minus 1. Start of the proof is shown below, and we are told to identify and correct an algebraic error and show the calculations to complete the proof. Now, Edexcel really liked these proofs recently. They did it in 2025, they did it in 2026, it could come up again in 2027. But let's go ahead and get into the question, right? Identify and correct any algebraic error, or an algebraic error, right? So let's just take a look, see if there's any algebra errors. And we see on this last line here, right, it's 10k, but it should be 20k, right? So we have to correct it so I can just demonstrate here. But 5k add 2 times by 5k add 2, we're going to get 10k squared, oh sorry, 25k squared. Add 10k, and then add another 10k, which is the mistake they made, right? So then it should be 25k squared, add 20k, add 4. And part B, show the calculations and statements that are required to complete the proof, right? Well, we're probably just going to be exhausting this, right? We're just going to have to keep shoving until it's reasonable enough to assume it applies to all cases, right? So obviously this is an exam, not an actual like proof we're trying to make, so all we have to do is just say, let's say m equals 5k add 3, the next number along. So that means m squared equals 5k add 3 squared. And we then expand these brackets, we're going to get 25k squared add 15k add 15k add 9. So that's 25k squared add 30k add 9. And then we want to factorize this so we can get 5n or 5n plus or minus 1, right? Like they did in this bit here. So if we then consider, if we add 1 to this, right, we get 10. So that makes it really easy to factorize, right? So we can just do 5 brackets, 5k squared, add 6k, add 2, right? And then obviously we added 1 here, so we just minus 1 here. Then we can just say that n equals 5k squared, add 6k, add 2, which then shows the proof, right? We've just shown that it's 5n minus 1. So then I guess we just kind of have to do this again, right? I probably would do it a couple times, like 2, 3, 4 times, just to show that you understand the proof. But I reckon because we get to 5k plus 4, that's 4 showing. That's 4 show that's right. So we should be good if we just do this one more time. So that'd be 25k squared. Move them brackets. 25k squared. Add 20k. Add 20k. Add 16. So 25k squared. Add 20. That's right. 40k. Add 16. Now we can factorize this if we minus 1 from this, right? Because then it becomes 15. So we just do 5 in brackets, 5k squared, and 8k, add 3. And then because we minus 1 here, we just need to plus 1. Then we've shown again there's 5n plus 1 this time. And we've showed all possible outcomes now, right? We've shown that it's plus 1, it's minus 1, and that is just n, right? Nice. And then it also says the statements, right? So we would just say, therefore, the square of any number can be expressed in the form 5n or 5n plus 1. Okay, question 9. We're told a racing car is driven along a straight road. And figure 2 is going to show a graph that represents the speed of the car. The graph starts from rest and is driven for t seconds before stopping, right? It's modeled by this equation here, where t seconds is the time after the car starts to move. According to the model, find the value of t. So the t is when the speed is 0 again, right? As we can see here, t is 0 at rest and t, or v is 0 at this point here. So all we have to do for part A, set v to 0. Then rearranging. And dividing by 2. Or t, sorry. Then taking lns of both sides to remove the e. Then dividing by 0.2. We get t is 13.5 into 1 decimal place. Part B says, show the maximum speed of the car occurs at this point here, right? So maximum speed, we're thinking maximum points, and we're thinking differentiation, right? So we're just going to have to differentiate this equation. So we have the equation V equals 15t minus TE 0.2t. So dV by dt, we can do this term by term. So 15t is just going to become 15. Now this is a product, right? Minus t times e. So we're going to have to use the product rule. So u equals t. V equals e to the 0.2t. du by dt equals 1. dv by dt equals 0.2 e 0.2t. So we can just do udv at vdu, which is 0.2 t e 0.2t, add vdu, which is e 0.2t. So our full equation then is dv dt equals 15 minus 0.2t e 0.2t and e 0.2t. So we found the maximum equation for the maximum speed, right? But we noticed that it's been rearranged in terms of t. So what we're going to have to do is find a way to make this all in terms of t. Well, at the maximum point, right, dv by dt will equal 0. So that means we can just say 15 then equals 0.2t, e 0.2t, and e 0.2t. Then we can factorize the e's out, right? And then all we have to do is times it by 0.2t and 1. Then we can make e the subject, right? So we can divide by the bracket. Equals e to the 0.2t. Then we can ln both sides to get rid of the e. Then if we divide everything by 0.2, we'll get 5 ln 75 over t add 5 equals t. Okay, which is this, right? Now part C gives us an iteration formula, and we're told to find the value of t3 and then find the time taken to reach the maximum speed, where t1 is 8, right? So the iteration is given by this. And we're told that t1 equals 8. So that means we can find t2 by subbing 8 in. And we get t2 is 8.76. And then we'll just use the answer function to find t3, which is 8.478. And then part II says to find by repeated iteration the time taken to reach maximum speed. So all we have to do is just keep pressing equals until we get a constant number. And we can see that it stalls at around 8.554. Okay, so question 10, we're given some vectors, and we have to find PR and show that the triangle it forms is right angled and isosceles. Okay, shouldn't be too bad, right? The easy way I like to represent this, even though it is 3D vectors, is just draw the triangle now for part A. Because we know we're going to have to prove it's eventually right angled and isosceles anyway, which would look a bit like this, right? Obviously straight. I don't know why it's not straight. Let's just fix that. So we draw the triangle P, Q, and R, right? P to Q is given by the vector 2, 8, minus 2, and Q to R is given by 6, 0, 6. And then we just need to find P to R. Well, P to R is going to be going P to Q, and then going Q to R, right? So this is going to be 2, 8, minus 2, add 6, 0, and 6, which is going to give us 8, add 8, and minus 2 add 6 is 4, right? Then make sure you change it from column vector form back to ing notation. I just think it's easier to work with column vectors for these questions. So that's PR, simple, right? Then part B says to prove that, or show that, it's right angled and isosceles. So for a triangle to be isosceles, two of its sides have to be equal, right? And we can see here there's going to have to be PQ and QR, right? Because the hypotenuse can't be equal to one of the lengths, right? So if we want to find the length or the distance of these sides, we're going to have to do the modulus, right? Or the Pythagoras of this function. So if we do this, we just do 2 squared minus 0 squared, obviously, add 8 squared, or minus 0 squared in total. Add minus 2 squared, obviously this will be all in brackets, but it will become positive anyway. So it's going to be 2 squared, add 8 squared, add 2 squared, which is going to give us 6 root 2. And then for the QR, it's going to be the same thing. It's going to be 6 squared, add 6 squared to find the distance. Then there's also going to be 6 root 2, right? So we've just proved that two sides are equal, so we can just quickly write, therefore, two equal sides. So isosceles, right? And now we're assuming that QR isn't the same distance for now, but we can prove it in this next part. So if we find the distance PR, which is going to be 8 squared, add 8 squared, add 4 squared, right? We get 12, and we see that these aren't equal, right? So we know it's not an equilateral triangle now. So we basically 100% confirm this isosceles. But we want to show that it's right angled. And what do we know about right angled triangles? Well, we know that a squared add b squared equals c squared, right? In a right angled triangle. So if we take lengths, here we say PQ is going to be A, and QR is going to be B, and the hypotenuse will be C, right? So we can then just say, to test if it's right angled, we can say 6 root 2 squared add 6 root 2 squared should equal 12 if it's right angled, right? Because A squared add B squared. So putting that into our calculator, we get an answer of 144, right? Which is equal to 12 squared. So we've proved that A squared and B squared equals C squared, so we've proved this right angled. So to make it a bit clearer, this is the proof for being right angled, and this here, and this here, is the proof that it is isosceles. And just to make it totally clear, this is the PQ, and this here is the QR. And this here is PR. Okay, question 11. The value of car is given by this equation here. A and K are positive constants, and T is the age in years. Always take note of this, right? I'm going to highlight this because you can't be dropping the marks in. Because you put it in months or something, right? So given that the initial value was 20,000, so that's when T is 0, right? And when T is 2.5, the value of the car was 12,000. Find the complete equation for the model, given the exact value of A and the value of K to 3 significant figures, right? So first thing I'm thinking about, if we write this model down quickly, so we know that when T is 0, V equals 20,000, so 20,000 equals 15,000, add A, times by e to the power of minus 0. Well, that's just like not, this is 0, right? Sorry, that's not 0, it's 1. So that means that A then add 1500 is going to equal 20,000. So that means A equals 18,500. So now we have A. Let's write the equation out again. And we want to find the value of K. So when T is 2.5, V is 12,000. So let's just put that in. 12,000 equals 15,000 plus 18,500 E minus 2.5K. Well, we minus 1,500 from both sides, we get 10,500 equals 18,500 E minus 2.5K. Then we divide both sides by 18,500 to get E on its own. We get 21 over 37 equals E minus 2.5K. Then we can ln both sides to get rid of the E, right? So ln 21 over 37 equals minus 2.5K. And then we will just put in the calculator to get a value, right? And then we'll divide that by minus 2.5 and we get that K equals 0.2265. K is 3 sig figs, so we're going to say 0.227. So that means our final model is B equals 1,500 and 18,500 E to the power of minus 0.277T. Oh, yeah, 227. Nice. Part B says, show that the rate of change can be expressed in this form. So rate of change with incident differentiation. For I'm noticing that we don't have any numbers really, we just have 1,500 from the original equation. So I'm going to think an easy way to do this, right, would be don't even use this model we just used, which seems counterintuitive, right? Because we just solved all that for no reason. But if we just write it here, it'll become much clearer. So if we take dv over dt, 1,500 becomes 0, and ae to the power of minus kt is going to become minus k ae minus kt, right? Which is pretty nice. We see that we now have this minus k, which we wanted. And now we just want v minus 1,500 somehow. So we're thinking substitution, right? So we want to get a minus e kt, a e to the power of minus kt on its own. So we can say v minus 1,500 is going to equal e ae minus kt. We can then substitute that into the dv dt equation, and we're going to get v minus 1,500, right? Pretty simple. And then part C says state a limitation of the model. There are loads of limitations you can choose from. Anything here from this B1 section will work. Question 12, we're given a sketch of curve C with the equation given here, and a straight line y equals 2x minus 10. Part A tells us to verify they both intersect. Part B tells us to find another point of intersection. And then part C asks us to use algebra to find the coordinate of this extra point of intersection, right? While part A verified that they both intersect when x is 6. If you look at the graph, x is 6 at this point here, right? So the way we can tell that they both intersect at this point is they'll both output the same y value for this x value, right? So let's put x is 6 into the straight line. So y equals 2 multiplied by 6 minus 10. That's going to equal 2, right? And then for the other one, it's going to be 15. What's what we would say? Y equals 15 multiplied by 6 all over 2 times by 6 is 12 and 3, so 15 times by 6 minus 3, which is just 3. So then 15 times 6 is 90, divided by 45 is just 2. So there we go, they both output the same value of y. We've shown that they both intersect at the point x equals 6. So the curve and the line also intersect at point Q, show that x is the coordinate of the solution. Well, if they both intersect at the point, that means their y values are equal to each other, like we've just shown, right? But this time we don't know what the x values are. So if we just say that 2x minus 10 the y values are the same, we'll just equate them. And we'll say 15x over 2x add 3 bracket x minus 3. So next thing we can do to make this a bit simple is we can expand these two brackets here at the bottom right. So it's going to be 2x squared minus 6x add 3x and then minus 9. It's 2x squared minus 3x minus 9. So then we'll just rub this out. And we'll say that it's 2x squared minus 3x minus 9. And now we can times that to the other side. So we can say 2x minus 10 multiplied by 2x squared minus 3x minus 9. It's going to equal 15x. And then expanding this bracket, we're going to get 4x cubed, which is, I believe, what we wanted in the question, right? 4x cubed, yes. Then 2x times minus 3x is going to be minus 6x squared. 2x times minus 9 is minus 18x. Then minus 10 times 2x squared is minus 20x squared. Minus 10 times minus 3x is going to be plus 30x. And minus 10 times minus 9 is plus 90. And that's going to equal 15x. Now tidying the left-hand side up, we get 4x cubed minus 26x squared. And we'll just check quickly, is that what we wanted? Yeah, that is what we wanted. And we have minus 18x plus 30x. That's just going to be minus 12x, right? Oh, sorry, plus 12x. Add 90 equals 15x. And then minus 15x from both sides, we get 4x cubed minus 26x squared minus 15x minus 3x add 90 and equal 0. Now, policy says using algebra and show all stages of working, find the exact x coordinate of q. Well, you might think we could use the quadratic formula, but it's not quadratic, right? You might think we could put it on a calculator, but that won't get you the marks. You could try and factorize it, but it'll be a little bit hard unless we notice it says use algebra. And then we also know here, it says when x is 6, these points are equal to each other, right? So we're basically saying this equals 0 when x is 6. And can we check that? Right? We can do 4 times 6 cubed minus 26 times 6 squared at minus 3 times 6 at 90 equals 0. So that means when x is 6, this equals 0, right? Which then means a factor would be x minus 6, right? If we were to factorize it. So now, we see that it said use algebra, we can think polynomial long division, right? So we just put this inside the bus stop. And then we say, what do we times x by to get 4x cubed? Well, that's going to be 4x squared. And then what do we times, so since we times these together, we have to times minus 6 times 4 together. So minus 24x squared. So minus 26 minus 24 is going to be minus 2x squared. Bring down to 3x minus 3x. What do we times x by to get minus 2x squared? It's going to be minus 2x. And then timesing those together, we get minus 2x squared. Minus 2 times minus 6 is plus 12x. Also, 112, 12x. Then minus 3 minus 12 is going to be minus 15x add 90. Then what do we multiply x by to get minus 15? It's going to be minus 15, right? So there we go, we have our other solution, which we can now see as a quadratic. So now we can just solve this using the quadratic formula, or if you have a good calculator, you can just solve it using the polynomial solver. I'm just going to use the polynomial solver. So we get x equals 1 root 61 over 4, or x equals 1 minus root 61 over 4. And then we see point Q is a negative x value, right? Let's streamline that. It's a negative x value. So that means we just have to take which one of these gives us a negative value, which is going to be x equals 1 minus root 61 over 4. Okay, so question 13, we're given another show that, which is just an integral between 2 and 0 for this function, and we have to prove that it equals 2 over 25, right? Well, there's a lot of ways you can probably go about this, but the way I'd recommend is just using a u substitution. I think that'll be the clearest way to do this. So if we let u equal 2x at 1, then du by dx is going to equal 2, right? So that means du equals 2 dx. So that means a half du will equal dx, right? And then now we need to do some rearranging so we can substitute u in for x, right? So we can say u minus 1 equals 2x. So you can say u minus 1 over 2 is going to equal x, right? So then if we take this integral here, where we have an integral between 2 and 0 for x and 2x and 1 cubed dx, well, we now know that x is going to equal u minus 1 over 2. Let's ignore the limits for now. U minus 1 over 2 all over, well, it's going to be u cubed, right? Because we said u is 2x at 1, so u cubed. All of that times by a half du. So that's going to make it now u minus 1 over 2u cubed times a half, which is then going to make it u minus 1 over 4u cubed du. And now we just need to find our limits for this, right? Well, the way to find the limits with u sub is when we said that u equals 2x at 1, right? So in this integral, x is going to equal 2 and x is going to equal 0. So when x equals 2, u equals 5. But when x equals 0, u equals 1. So these are now our u limits. Now, next thing we can do is split this integral up. So we can say u over 4u cubed, which is just the same as cancelling this u out, lowering this to 2, which is just the same as then a quarter u minus 2, or a quarter 1 over 4u2, which is then 1 over 4u to the minus 2. And we also have minus 1 over 4u cubed, which is just minus a quarter u to the minus 3. So now we can integrate this between 5 and 1. So adding 1 to the power, minus 2 and 1 is minus 1. A quarter divided by minus 1 is going to be minus a quarter to the minus 1. And then minus 3 and 1, minus a quarter divided by that is going to be 1 over 8 u to the minus 2. And then we just simplify the 1, right? So minus a quarter times 5 to the minus 1 and 1 over 8 times 5 to the minus 2 is minus 9 over 200. So we get minus 9 over 200. And then subbing in 1, we get minus a quarter times 1 to the minus 1 and 1 over 8 times 1 to the minus 2. And we get minus 1 over 8. So minus 1 over 8, which then gives us 2 over 25. Okay, so question 14 here. We have okay, so question 14 here, we're given a show that where we have to prove that this left side is similar to the right side, right? And then we have to solve this right side when it's equal to 3 sine theta. Okay, well, if we take part A, we can see here that we have the sine addition formula, right? We're adding two things together inside the bracket of sine. So sine A plus B equals sine A cos B and cos A sine B. So let me just see here that A is going to be x and B is going to be 30, right? So it's going to be sine x cos 30 and cos x sine 30. Simple, right? And then we move to the right here, we see that we have just root 3 cos x and 30, right? So that's going to be the cos addition formula this time, but all of it multiplied by root 3. So the cos, or the cosine addition formula, is going to be this, right? Cos A, cosine A, cos B, minus sine A, sine B, right? And the minus sign is very significant here, remember? The cosine one has kind of the opposite as the addition formula for the sine one, right? So let me just see that x is going to be a again and b is going to be 30 again, right? But remember, this is all multiplied by root 3. So it's going to be cos x cos 30 minus sine x sine 30, all multiplied by root 3, right? So next what we can do is we can use our real trig values, right, or our trig identities. So cos 30 is going to equal root 3 over 2. And sine 30 is going to equal a half, right? So then if we just simplify everything here, we have sine x times cos 30, which is root 3 over 2, and cos x times sine 30, which is a half. So we're going to have root 3 over 2 sine x. And 1/2 cos x. And this comes from the sine part, which I will just draw a red line to reference the sine part, right? And then we look at the cosine part. Well, we're going to have cos 30 times cos x, so that's going to be 3 root 2 cos x. So we'll just bring this down here. Remember, this is still all multiplied by root 3, right? So then it's going to be cos 30 times cos x, so 3 root 2, or sorry, root 3 2 cos x minus a half sine x, right? And this is all multiplied by root 3, so then we can just finish this off here, right? We can say root 3 times by root 3 over 2 is going to be 3 over 2 cos x and cosine x. And then the root 3 times minus a half is going to be minus 3 root 2, right? Oh, sorry, minus root 3 2 sine x. And then we just have to look what cancels out, right? Just to clear this up, this comes from the cos addition formula, and then the red comes from the sine addition formula. So then we just take these away and simplify it, right? So with root 3 over 2 minus root 3 over 2 cancels out, or is 0, and then a half at 3 over 2 is going to be 2, so that should simplify this to 2 cosine x. Okay, then part B says solve in the range of 0 to 180 degrees. This sine cos equals 3 sine 2 theta, right? Well, we've already proved that this is this, right? So we can just use 2 cos x here to make it clear, right? The only thing we have to do is change x to theta, because we're not solving for x, we're solving for theta, right? So for part B, we're going to say 2 cosine theta is going to equal 3 sine 2 theta. Okay, the next thing we can do is we can use we can use the sine double angle identity, right? So we can say 2 cosine theta is going to equal 3 lots of 2 sine theta cos theta. Alright? And then if we expand that bracket, we get 2 cosine theta equals 6 sine theta cosine theta. And then we can minus 2 cosine from both sides, so we get 0 equals 6 sine theta cos theta minus 2 cosine theta. Then we can just take a factor of cos theta out and cosine theta out. That's going to be multiplied by 6 sine theta minus 2. So then we have two things to solve, right? We have cosine theta equals 0, and we have 6 sine theta minus 2 equals 0. So for the cosine equals 0, right, you can just put this in your calculator and you'll see that it gives you 90 degrees. And then the next one along is just going to be 360 minus that when x is 0 again, which is 270 degrees. We know this is out of the range, right? So we can just ignore that one. So we have one solution here, 90. Next, we're going to say 6 sine theta equals 2. So sine theta equals a third. Then using our calculator, sine inverse of a third, we get 19.47 degrees. And then for the sine graph, it will be 180 minus that, which will give us 160.5 degrees. So then if we just simplify this, it will be 90 degrees, 19.5 degrees, and 160.5 degrees. And now just to explain the sine graph, because it can be a bit confusing compared to 0. Draw a nice little sine graph. So we're told that sine theta is a third, right? So if we move along, draw a straight line, this is not exactly where a third is, right? But we're just assuming it's around it. So the first thing we did is we found the point where equals a third, which is here, right? Which is going to be 19.47 degrees. And now the next time it does it, at this point here, which is just before 180, right? Because we have here, we have 90, then we have 180, then we have 270, then we have 360, right? So then it's just going to be 180 minus 160.5. Okay, question 15. We're given the plan to design a stage. We're shown a sector AOB and a rectangle OBCD. The radius of the sector is R, and the angle AOB is theta radians. The length and width of the rectangle are R and 1/10 R meters, respectively. The total area of the stage is 240 meters squared, and we're told to show that the perimeter is given by this equation, right? Well, we see radians, we see sectors. We know we're going to be using the area of the sector formula, right? So first things we can do is say the area of the sector is given by 1/2 times r squared times theta, right? Now r squared is just the radius. We're told the radius is r, and theta is just the angle of the sector, which is also theta. So that means the area of this sector is just going to be 1/2 r squared theta, right? And then to find the area of the rectangle, right, we're just going to do length times width, so 1/10 times r, which is going to obviously be 1/10 r squared, right? And that's going to equal the area, which is 240 meters squared. Now, if we look at this, we have the area, we want to convert to the perimeter, right? And we see that the perimeter only has values of r in it. It doesn't have values of theta, right? So the next thing we can do is we can rearrange the equation of the area in terms of theta, right? So let's do that. So 240 minus 1/10 r squared is going to equal 1/2 r squared theta. And if we divide everything by 1/2 r squared, we'll get theta on its own. Now we can simplify this afterwards, right? But we just want to show that we have theta on its own. And the next thing we want to do is determine the perimeter of the sector, right? Otherwise we're not going to be able to get an equation of the perimeter if we don't have the general equation of the perimeter. So first thing we need to do is we need to find the arc length, right? Because that's the only length we don't actually know. And the arc length for a sector is given by a length equals radius times angle, right? Now we know the length, also we know the radius is r, we know the angle is theta, so that means that the arc length is just going to equal r theta. Right? And then we need to find the perimeter, so we need this for the perimeter. And this here, right? So adding these two r's, we're going to get, I'm sorry, not this one, we just need r here and r here, right? So it's going to be add 2r. So perimeter equals r theta, add 2r. And then we need to add these two widths, right? So 1/10 add 1/10 is going to be a fifth. So it's going to be add 1/5 r. So then now we have an equation of the perimeter, but we still have theta, right? And we see in our final answer we don't want to have theta. So we're going to substitute our equation for theta into r, and then we'll get a p just in terms of r, right? So now we just have to substitute theta in, right? So r multiplied by 240 minus 1/10 r squared over r, a half r squared, right? And 2r at a fifth r. So we multiply through, it'll be 240r minus 1/10 r cubed over 1/2 r squared. Then divided by r to simplify it. We'll get 240 minus 1/10 r squared over a half r. Alright? And this is going to be adding on 2r and adding on a fifth r. So then we can simplify the fraction, right? We'll say 240 divided by a half. It's going to be 480 over, divided by half r, so 480 over r. Then minus 1/10 divided by half r. It's going to be minus a fifth r. Add 2r, add a fifth r. Now these are going to cancel out as we're adding them together to make 0. Which then just leaves us with 480 over r add 2r, which is what we are told to find in part A. Now part B says, using algebraic differentiation, find the value of r for which p has a stationary value. So we know we're going to have to differentiate this to find the stationary point, right? So let's rearrange this into index form first of all. Say 480r minus 1, add 2r. Then taking dr by dt, it's going to be minus 480 r to the minus 2, add 2. And then now we've differentiated it, we need to find the value of r where we're at the stationary point, right? So that means the derivative is going to be equal to 0. So 480 r minus 2 equals 2 now. Then to make it clearer, you can just write it like this again. Now we can just solve for r, right? So 480 equals 2r squared. So 480 divided by 2 is 240. And square rooting that, r is going to equal 4 root 15. Now part C, this is proved by further differentiation that this value of r gives the minimum. So what do we know about the minimum? And we know that the second derivative has to be greater than 0, right? So let's go ahead and find d squared r by dt squared. Well, we differentiated it to minus 480 r minus 2. So times by minus 2 and minus from the power, we're going to get positive 960 to the power of r minus 3. And then the 2 is going to dissipate, right? So then it becomes 960 over r cubed. And then we're just going to substitute our value of r in, which is 4 over 15 cubed. And then 960 divided by that gives us 0.25819, which is greater than 0, therefore minimum point. Okay, final question, number 16. We're given a sketch of a curve with this equation here, and we're given the region R, and we're told to use the substitution x equals 2 sine u to show the area is given by this, and then use the integration to find the area. Okay. So, first things first, let's just write out there we go. And then we're told to use the substitution of x equals 2 sine u. So whenever we're using integration by substitution, right, we're always going to want to differentiate our substitution, right? So dx by du is going to be 2 cos u, which then means dx equals 2 cos u du. And then we see that we have du here, right? So that means we're going to be substituting du in. So it's going to be, then we're going to rearrange for du, so it will just be 1 over 2 cos u. My pen's playing up a bit. 2 cos u dx x is going to equal du, right? So that's our first part, right? Because right now our integral is looking like this, right? Then we want to change this integral into the form given above, right? So next thing I'm thinking, we have the substitution x equals 2 sine u, but in our integral, we have lots of x squareds, right? We have x squared here, we have x squared here. So let's just square x. So we set that x equals 2 sine u. So x squared will therefore equal 2 sine u times 2 sine u, which is 4 sine squared u, right? So then now we can just sub in our sine squareds, right? So we're going to have 1 over 4 sine squared u multiplied by the square root of 4 minus 4 sine squared u. And remember, we're going to... sorry, this rearranging here we don't need to do. We're just going to multiply it by 2 cos u, right? Because dx equals 2 cos u du, so times by 2 cos u du. And now we need to try and think of a way to simplify this, right? Well, we can notice that this 4 minus 4 sine squared u here, it kind of looks like this, right? Sine squared u and cos squared u equals 1, right? It looks like that, but rearranged. So we can just say that cos squared u equals 1 minus sine squared u. The only difference is now it's been square rooted and multiplied by 4, right? So that means 4 cos squared u equals 4 minus 4 sine squared u. And then it's just the square root of that, right? Well, the square root of 4 cos squared u, if we square root both sides, it's just going to be 2 cos u, right? So now we have 1 all over 4 sine squared u times cos u, or sorry, 2 cos u, because that's the square root, right? Multiplied by 2 cos u du. And then we'll see that when we multiply these together, the 2 cos u's will cancel out. And we'll be left with 1 over 4 sine squared u. Now we know that 1 over sine is cosec, so 1 over sine squared is cosec squared. So that means this is the same as 1 over 4 cosec squared u. Right? And du, don't forget that. And then now we just need to find our limits, right? Remember we said our substitution is x is 2 sine u. And then we can see in the graph the area is embedded by root 3 and 1. So let's find our upper limit, which is going to be when x is root 3, right? So x equals root 3. So solving for sine, we get root 3 over 2 equals sine u. Sine inverse using our calculator for root 3 over 2 is going to give us 60 degrees, but in radians, because we're doing integration, right, it will give us a third pi, or pi over 3. And then when x is 1, the lower limit, a half equals sine u. So sine inverse of a half, well, that's just going to be pi over 6, right? So there we have our 2 limits. And obviously, we know that pi over 3 is greater than pi over 6, right? So our final integral will just be given by this. A quarter cosec squared u du between pi over 3 and pi over 6. And there we have shown what b and a are, and we've shown k as a quarter, right? So now part B says, using algebraic integration, find the exact area of R. Well, notice there's only 3 marks, right? But something interesting about this is there's not really an easy, like, known way, I guess, to integrate cosec squared u. You could maybe try either product rule or something, or like use a substitution, I don't know. There's many ways you could try and do it, but there's a really easy way using the formula booklet, right? So if we pull this up here, right, we see that the derivative of cot x is minus cosec squared x, right? So going downwards, differentiating cot x, we get cosec squared x, right? So all that means is if we integrate minus cosec squared x, we're going to go back to cot x, right? And what we're doing here, we're integrating cosec squared. But we notice there's a minus and a positive, so we're just going to have to put the sign right? So say we were integrating minus cosec squared, we're going to get cot x. So we're integrating cosec squared, we're going to get minus cot x, right? So the integral is just going to be a minus quarter, because it's what we had here. And then the integral of cosec squared is going to be cot, right? So it's just cot u. And then now all we have to do is substitute in our limits of pi over 3 and pi over 6. For minus a quarter, cot u. So obviously we can't put cot in our calculator, so it's going to be minus 1 over 4 tan pi over 3. And we're going to get minus root 3 over 12. And then putting pi over 6 in our calculator, we get minus root 3 over 4. Then if we take these away, we get root 3 over 6. And that's the final answer.